It's a question from the Sapling for Class Activity 9A. It's number 15, and I wanted to go through this and answer the student's question. Now, this was the class activity on SN2, but I wanted to go through this and talk about it as though maybe you didn't know if it was SN1, SN2, E1, or E2, and show you how you could predict what would happen. So first, let's look at our substrate. We can see that it is a secondary alkyl halide. Bromine is priority 1, the ethyl group is priority 2, and the methyl group is priority 3, and the hydrogen is priority 4. So if we look at that, we can see that this must be S2-bromobutane. Our nucleophile is sodium cyanide, or more specifically, the cyanide ion is our nucleophile. This is not a strong base. It's the conjugate base of HCN, which has a pKa, I think, of around 3 or 4. So it's not a very strong base. It's a good nucleophile. And now we want to look at our solvent, which is DMSO, which recall is a polar aprotic solvent. So we've got a secondary substrate, which we know it can do anything, but we've got a polar aprotic solvent, which is not going to encourage the formation of carbocations. So that can tell us that probably it's not as likely it's going to do an E1 or an SN1 reaction. We have a nucleophile that is not a strong base and is a good nucleophile, and so that is going to promote a SN2 reaction over an E2 reaction. So we're going to do an SN2 reaction here. So I'm going to leave out the Na plus because that's just a spectator ion, and just focus in on the nucleophile. This is an SN2 reaction, so the nucleophile is going to come in from the opposite side as the leaving group, which is bromine. I'm going to abbreviate this group as CH3, CH2, just so you can see it a little more easily. So here's the product of our reaction. And if we go around and we know that the CN is going to be priority 1, we know the ethyl group is going to be priority 2, the methyl group is going to be priority 3, and the hydrogen is going to be priority 4. The hydrogen's oriented to the back just like it was in the starting material, so it's easy to see that that is clockwise, and therefore the substitution product is R. And recall, for SN2 we would expect to have inversion of configuration. Now, the student that asked this question did get this answer. The question they had, however, is, notice here is the answer that I had drawn previously. It's exactly the same. And one of the things I've done here is I've built a model of it. And so you can see that, here this is the CN group, this is the ethyl group, here's the hydrogen, and here is the CH3 group. So this model represents this compound. So the student question, they had drawn the molecule in this way, where the CN is coming out at you, and we're asking, and that the student question was, is this the same compound? And the answer is yes, it is exactly the same compound. It's just drawn in a slightly different orientation. This model that I have in my hand is exactly the same model. Here is the ethyl group, or excuse me, CH2CH3 group, which is also ethyl. Here is the hydrogen. Here is the CN group, and this is the methyl or CH3 group. So these two, they're exactly the same model. They are just oriented a little bit differently, and so you might want to practice a little bit with your model kit and make sure that you got that down.